Alright, so today we are going to be talking about solving systems with Cramer's rule. So we're going to be utilizing matrices to solve systems of equations. So first we're going to look at the coefficient matrix. So first, there's two things we're going to look at here. If we're given a linear system, like x minus 5y equals 9 and negative 7x plus 2y equals negative 30, negative 30, the way we find the coefficient matrix is we just take the numbers in front of x and make a column out of that. So we're going to have 1 and negative 7. And then the numbers in front of y and do the same thing. We're going to have negative 5 and 2. That's our coefficient matrix. So what we can say is Cramer's rule is named after the Swiss mathematician Gabriel Cramer, and it uses the coefficient matrix and determinants to solve a system of linear equations. So let's look at the actual format of how we do this. So we're going to start by making a little bullet point here and say given the system, we'll call it ax plus by equals e and cx plus dy equals f. We can let big A be the coefficient matrix, which we would have A, B, C, D. So this is the coefficient matrix. We let that happen. So then we say if the determinant of A, if the determinant of our coefficient matrix does not equal 0, then the system has a unique solution, which we can just say has a solution. And we can write the solution as x equals the determinant of the matrix E, B, F, D over the determinant of our coefficient matrix, and the y value is equal to the determinant of the matrix A, E, C, F over the determinant of our coefficient matrix. And just a little side note, if the determinant of the coefficient matrix does equal 0, then the system does not have any unique solutions. It either has no solution or it has an infinite number of solutions. So in example 1, we're given the system x minus 5y equals 9 and negative 7x plus 2y equals negative 30. So we're going to first write our coefficient matrix, A, as 1, -5, -7, 2. And then we're going to also, while we're at it, find the determinant of A. So remember, we go 1 times 2 minus -7 times -5. So 1 times 2 is 2, minus -7 times -5 is 35. 2 minus 35 is -33. So now to find the x value of our system, the answer, solution, we're going to take the determinant of 9, -30, they are in the place of E and F, then -5, 2, we're going to find the determinant of that and divide it by our -33. So we're going to go 9 times 2 minus -5 times -30. So then divide that by -33. 9 times 2 is 18. Minus 5 times 30 is 150 over -33. And 18 minus 150 is -132 divided by -33, which is going to give us a positive 4. So in our solution, we know the x coordinate is 4, the x value is 4. To find y, which I'm going to do that in a different color, I'm going to do that here in blue. To find y, we're going to take A and C, 1, -7, and then E and F, 9 and -30. And divide that determinant by -33. So we're going to have 1 times -30 minus 9 times -7 divided by -33. So we're going to have -30 plus 63 divided by -33. And -30 plus 63 is 33 divided by -33. It's going to give us a y value of -1. So our answer is going to be 4, -1. Now we're done with that one. Let's look at example 2. On example 2, we have the system 2x plus 6y equals 38, and 5x plus y equals -3. So now we're going to write our coefficient matrix A. We're going to have the first row 2, 6. The second row we're going to have 5, 1. So then we find the determinant of A. So we go 2 times 1 minus 5 times 6. 2 times 1 we know is 2, minus 30 is going to be -28. So now we can find x. X is the determinant of EF for the first column. So 38, -3 for the first column, and the second column is BD. So 6, 1 over -28. So we're going to have 1 times 38, which is 38, minus -3 times 6 is -18, so plus 18, divided by -28. 38 plus 18 is 56, so we're going to have 56 over -28, which is going to give us -2. So our solution, x value is -2. Then we can find y. We're looking for the determinant of 2, 38, 5, negative 3, divided by negative 28. Well, 2 times negative 3 is negative 6, minus 5 times 38 is 190, divided by negative 28. So we're going to have negative 196 divided by negative 28. So I just type that into my calculator, and I get that that equals 7. So our solution is going to be negative 2, 7 to that system. Let's check out example 3. Example 3, we have the system 6x plus y equals negative 22, and negative 3x minus 2y equals 17. So first we find our coefficient matrix. We're going to have in our first row 6, 1, and in our second row negative 3, negative 2. We find the determinant of that. So we're going to have 6 times negative 2 is negative 12, minus negative 3 times 1 is negative 3, so negative 12 plus 3. We're going to have negative 9 for that determinant. So to find our x value, we're going to take negative 22, 1, 17, negative 2, the determinant of that divided by negative 9. Negative 22 times negative 2 is 44, minus 1 times 17 is 17, divided by negative 9. Well, 44 minus 17 is 27. It's 27. Divided by negative 9 is going to give us negative 3. So our x value is negative 3. Now for y, we're going to go 6, negative 22, negative 3, 17, divide that by negative 9. So we're going to find the determinant of that top part. 6 times 17 is 107, minus 3 times 22 is 66, divided by negative 9. 107 minus 66 is... Now, I made one error. That 6 times 17 is not 107. It's actually 102. And when we subtract 66 from 102, we get 36. So 36 divided by negative 9 is going to give us negative 4. So our solution is negative 3, negative 4. Now we could plug these points back in to the two equations and make sure they satisfy them. They do. So now let's look at Cramer's rule for a 3-variable system. So we can say, given a system ax plus by plus cz equals j, and dx plus ey plus fz equals k, and gx plus hy plus iz equals L, we can let our coefficient matrix A equal, our first row is A, B, C, second row is D, E, F, and G, H, I. That's our coefficient matrix, and as long as the determinant of A does not equal 0, then the system has a unique solution, and X is found by taking the determinant of J. In fact, I need a little bit more room for this. x is found by taking the determinant of JBC, KEF, and LHI divided by the determinant of A. Y is going to be the determinant of AJ, C, B, K, F, and C, L, I over the determinant of A. And I need a little bit more space for Z. Z is going to equal the determinant of A, B, J, B, E, K, B, E, K, and C, H, L, all over the determinant of A. So we're just going to look at one example of a three-variable system and then call it good. So on example 4, we have the system negative x plus 7y minus 2z equals negative 14, 2x plus y plus 9z equals 43, and 3x minus 5y plus 2z equals 2. First, our coefficient matrix is going to look like A equals negative 1, 7, negative 2, 2, 1, 9, and 3, negative 5, 2. Now, with these, we can also use our graphing calculator to find the determinant of A, which is exactly what I did. The determinant of A in this case is going to be 140, which means x is going to equal, x is going to equal the determinant of negative 14, 7, negative 2, 43, 1, 9, and 2, negative 5, 2 over 140, and again, I would just use my calculator. This top determinant is going to be negative 700 divided by 140, which is going to give us an x value of negative 5. So now let's find y. Y is going to be the determinant of negative 1, negative 14, negative 2, 2, 43, 9, and 3, 2, 2 over 140. And again, I would use my calculator. The determinant on this top part is going to give us negative 140 divided by 140, so negative 1 for y. And then we've got one more part to find. Z is going to be the determinant of negative 1, 7, negative 14, 2, 1, 43, and 3, negative 5, 2 divided by 140. And again, using my graphing calculator, I'm going to find that the top gives me 840 over 140, which simplifies to 6. So my answer is negative 5, negative 1, 6. And we're going to actually call this good. We're done with our lesson on solving systems with Cramer's rule.